again we are going to continue this problem. So the first step here in this problem so far we have seen is we have to compute the stiffness matrix. So what is the general finite element equation? What is the general finite element equation? F is equal to K into U. So in elasticity we have computed F is equal to K into U, where F is the force matrix, K is the stiffness matrix, and U is the displacement vector. So this is what the general finite element formula. So whenever you are asked to write the general finite element formula, what you will write? F is equal to K into U. That is for elasticity. Now you are solving it for heat transfer. So instead of U, you will write it as T. What? T. Instead of U, you will write it as T. So here the general finite element equation is always for thermal problem F is equal to K into T. So now you can say F is the force vector, right? K is the stiffness matrix and T is the temperature of the, right? So this is how you have to solve this problem. So how will you solve? If you compute what is the value? So please say louder. 8.5 divided by 0.25. 34. Right. Are you all getting 34? 34 into 1 minus 1 minus 1 1. This is for the element number 1. Stiffness matrix for element number 1. Similarly, compute for element number 2. K2. What is K2? Again the area A1 and A2 is 1 meter square and thermal conductivity K2 is 0.25 divided by length of the element 2 is 0.05. So please be careful while substituting the values. Yes. So what is the answer? 5 5s are 25. Am I right? So you will be getting 5. Is it right? Yes? Sure. Yes. 5 into 1 minus 1 minus 1. Similarly, we have to compute for the element number 3. Stiffness matrix for element number 3. Element number 3, again the area is 1. And there the K value, thermal conductivity of the material layer number 3 is 0.08 divided by L3. Thickness of the element number 3 is 0.03 into 1 minus 1 minus 1 1. So 2.67. Very good. So 2.67 into 1 minus 1 minus 1 1. So this is for the stiffness matrix for element number 3. So far in step number 1, what we have found out? We have found out all the unknown values of stiffness matrix. So K1, K2, K3. Now the next step, step number 2, what you have to do is, you have to substitute the values in terms of the general finite element equation. So how will you substitute? F is equal to K into T. So K is known and T is also known. So there is a minor change in this problem. Could someone guess the change? There is a minor change in this problem. Could anyone be able to identify the change? Look into the diagram first. Please look into the diagram. See, listen here. So I will tell you what. So the heat, what do you mean by a furnace? What do you mean by a furnace in general? A furnace is a device where heat is produced and it is used to do some work. Am I right? Example, furnace is used in a foundry where it is used to melt the metals. Am I right? So this is what your problem in finite element, right? This problem you are solving using finite element. So here, this furnace, the inner layer means here the temperature is in effect. Am I right? So here the material is melted. So that material temperature is conducted here. So here it is conduction, right? So this is layer number 1. So from this layer to the next layer, it can be some other material. Like the furnace, if you see how the important buildings are built, there will be a steel structure inside. Am I right? TMT bars. Am I right? Then concrete is laid. Am I right? Then it is packed with cement. Am I right? Then it is painted. Likewise, here the furnace, the first layer is having some material, the second layer is also having some material. The heat is conducted from this area to this area. Right? From this area to this area, again there is one more material or one more layer, the heat is conducted. So at the end of the third layer, what it is there? Convection. So where convection happens? The third layer. So if in such case, what you have to do is you have to use the convection formula. So there is a formula for convection. So in order to find the convection, that is H into T infinity 0, 1. So this is the formula for convection. We will see how it is applied in the step number 2.